All right, class, this is going to begin our work through, in our textbook, Module 7. We're going to be working with angle relationships and parallel lines. In a subsequent video, we're going to look at angle relationships and triangles, and then we're also going to look at Pythagorean's theorem and its converse. And so, but for this video, let's just start off, with the foundation of it. I want you to look at this diagram right here. We have two lines, line L and line M, and you already know this. This little red box right here, that means that these lines are perpendicular. And so we could actually write that like this, that line L is perpendicular to M. That would be one way to write that. They form a 90-degree intersection. When they cross, the angle formed 90 degrees. Let's look over at the second diagram here. What we have is line S and line T. And if you'll notice these two small red arrows, what those are trying to indicate is that these two lines are parallel. So we think in our world, the most obvious example is train tracks, meaning that they are theoretically the same distance apart regardless of how far they run. So if they run all the way to infinity, which theoretically they do, they are always the exact same distance apart. Now this line is something that we call a transversal. And how this helps us is we want to begin to look at how these angles, and I'll just start numbering them, 1, 2, 3, 4, 5, 6, 7, and 8. As this transversal, this line right there, crosses two parallel lines, it creates, in this case, two sets of 4 angles. And all these angles have a relationship. And so hopefully you'll notice over here to the right, I have some classifications. And this is like the foundation for what you'll do later in geometry. Thankfully not this year, right? Not in the 8th grade. But for proofs. And what we're trying to do with these classifications is learn some rules and how they apply and how they help us relate angles to one another. For instance, a supplementary set of angles, it's consecutive angles, and we know they add up to 180. Now, what in the world do I mean by that? It means that angle 1 and angle 2, they're consecutive angles across this line. And a straight line, if you think of a protractor, this might help. If you think of a basic protractor, this would be 0 degrees, and if you go all the way around halfway, you've gone 180 degrees, and we know the whole distance is 360 degrees. Well, what's formed when I go halfway around? A straight line. And that's where that 180 degrees comes from. So if this line S is a straight line, which it is, consecutive angles along that line, in this case 1 and 2, are supplementary. I could say this, angle 1 plus angle 2 equals 180 degrees. How do I know that? Well, they're supplementary. That's how I would classify them. We could say that angle 1 plus angle 2 is 180 because they are supplementary, consecutive angles. Well, we also have corresponding angles. Now, corresponding angles would be something like, say, angle 2 and angle 6. Notice how, if you think of quadrants, quadrant 1, 2, 3, and 4, and then for this lower one, this lower set of angles, you have 1, 2, 3, and 4. Notice how that angles 2 and 6 both occupy angle 1. All right, that means angle 3 and angle 7 would also be corresponding angles. They're both occupying the quadrant 3 part of that set of angles. So they are the same. Alternate interior angles. All right, alternate interior, try to change colors again. 5 and 4 are equal to one another. So we could say that angle 5 equals angle 4. Why? Because they are alternate interior angles. And what we mean by that is they're on the interior. They are inside the two parallel lines, but they're on alternating sides of the transversal. 3 and 6 would also be alternate interior. Alternate exterior would be, let's say, 1 and 8. Notice that they're on the outside of the parallel lines, but they're on alternating sides of the transversal. 7 and 2 would be congruent, and we can prove that by alternate exterior angles. The last one that we'll do quickly is vertical angles are equal or congruent, and this would be like 1 and 4. They are opposite one another. All right, 5 and 8 would be congruent. 7 and 6. So those opposite angles are going to be the same. Now what you'll find is a lot of times you can prove these by using different classifications. All right, we'll try to make that make sense as we look at a couple of quick examples. All right, so here in this first example, I have a very similar scenario, but I've given you angle 1. I've told you that angle 1 is 120. Let's just do a few samples here. That means I could say that the measure, that's what the M means, of angle 2 is equal to 180 minus 120, or 60 degrees. Now, no, I know it's a straight line. If this is line L, that's a straight line. And this angle, which would be angle 1 and angle 2, are supplementary. So that would be my justification. Let's see, the measure of angle, let's say 4, would be 120 degrees. Why? Vertical angles. I'll just leave it as VA. Vertical angles are congruent. What about the measure of angle 5? Well, it's going to be 120. Why? Corresponding. Think about it. Angle 5 and this angle here occupy the same spot on these respective groups of angles. Oh, let's see here. What about the measure of angle 8? Well, it's going to be 120 degrees also, but why? Alternate exterior. All right, so that's just a few examples. I hope that begins to make sense. Go ahead and pause the video and try to apply these rules to this practice problem over on the right. All right, well, let's go ahead and start solving this. I've given that measure of angle 7, that's this one, is 40 degrees. So 6 is going to be 40 degrees because of opposite angles. 8 is going to be 140 degrees because it's supplementary not only to angle 6, but also to angle 7. Angle 5 is going to be 140 because of vertical angles are congruent. So 5 and 8 would be vertical. They're going to be the same. But it's also supplementary with 6, and it's supplementary with 7. And so if we just use corresponding at this point, 1 is 140, this is 40, 2 is 40, and 4 is 140. All right, let's do some more examples. You'll notice I've added a little bit more to this one, but all the principles are going to be the same. I know that the measure, of angle 1 is 40 degrees. Well, what's going to be angle 10? Well, it's going to be 140. Should have changed my numbers here. 2 is going to be 140, and 9 is going to be 140. All right, now, what in the world do we do here? Like, what would be, let's say, angle 5? What if we were to do that? What's going to be angle 5? So let's think through this. Now, you really have to think through this because corresponding, I think, is one that's very helpful. And so I know that angle 1 and angle 3 are corresponding. How do I know that? Because line L and let's just say line M are parallel lines, and this alpha here, this orangish line, is the transversal. So angle 1 and angle 3 are going to be corresponding. So angle 3 is 40. Watch this. 7, 8, and 3 all add up to 180. So we could say angle 7 plus angle 8 plus angle 3 is equal to 180. In that case, all three of those angles are considered supplementary. Well, I don't know angle 7, so let's just leave it like this. Angle 8 I know is 90, and angle 3, if using corresponding, I just solved this 40, and all of that's supposed to equal 180. All right, let's combine our like terms. That's going to be 130. I'm going to subtract 130 from both sides and get 50 degrees. So now all of a sudden, I know angle 7 is 50 degrees. Now think about where we can go from there. Angle 4 is going to be vertical angle to 7. All right, so that's going to be 50 degrees. Angle 8 and angle 5, wait, look at that. These two, and with combination, with this with this line, those are vertical angles. So I know that that's 90. 6 is a vertical angle to 3, and that's 40. 40 plus 50 is 90, plus 90 is 180, and I know those are supplementary. So hopefully that gives you an idea of how you can work through these to solve for the various angles. So go ahead and Pause the video, try this practice problem. All right, so in this case, the measure of angle 3 is 58, and that means that 2 is going to be 180 minus 58, which would be 22 degrees. All right, angle 1 is opposite 3, so that's going to be 58 degrees. 4, oh, wait a minute, looks like I have made a mistake there. Hopefully you caught my mistake. That should be 122 degrees, and so that means 4 is 122 degrees as well. Now we think of corresponding. Angle 5 corresponds to angle 1. We know that because of this parallel line and that parallel line and how they work together with the transversal. All right, I know that's 58, that's 90, so angle 7, the measure of angle 7 is going to equal to 180 minus, what, angle 5 plus angle 6. And so angle 7 is going to be 180. What's angle 5? Well, it's 58. Angle 6 is 90. All right, so angle 7, look, 58 plus 90, that's 148. That's going to be 52 degrees, right? So we've got angle 7 as 52 degrees. And so from here, we know that if angle 7 is 52, that's 52. 9 is 90 because the vertical angles are congruent. And that one is 58. We can double check our math. If I add 2 to 58, that's 60. That's going to give me... All right, so this video is some proof that it's so easy to make math mistakes. That is not 52 degrees, that's 32 degrees, which makes this one 32 degrees. And hopefully if you were paying attention to the video as I worked through that, I began to mentally go back and check my work. And I plead with you to do that because it is so easy for all of us to make simple little arithmetic errors. And if we don't go back and check, everything kind of goes downhill from there. All right, so let's look. Oh, actually, I think that was the last one. All right. So look, work through these, pay close attention to them, and just keep practicing.